Hello everyone, in this tutorial we are going to see Introduction to Object-Oriented Programming. We have already finished with functions and different statements which are involved with C and C++. Now, one major thing which is going to introduce us to object-oriented programming is going to be the data structures. What are data structures? Data structures are structures just like classes which are taking up certain values and are giving up these values into the functions with different characteristics of parameters they contain. It may seem complicated now, but when you are going to see example, it will look much more easy. But let's start with what is object-oriented programming. You need to know that, example, when you have this include IOStream and using namespace std, know that this should have the function count in it. Now, we need to know that inside Java, they are considered, all these IOStream, namespace std, they are considered as classes and packages. So in order to call these functions inside the main function, because the main function is in a particular class on itself, you have to take it as top level and lower levels. Let's say that you have a small box and you have a larger box which is containing the small box, and you have again another box which have a smaller box. It's just taken at this. You have a main small box and a main larger box. It is from the main small box and the main larger box that you are capable to arrive to other boxes. That is how object-oriented programming is considered. It is from the main small box and its larger box. The small box here is considered to be the main function. The larger box is considered to be the class of main function, going to see in Java, and the other boxes are the other classes. Now, in order to call a class, because these classes are containing functions in it, you have to call this function like count from another class into the main function. In order to call them, you have to use this format. This, you say the object dot the function. This is a format you use when you want to call one function which is inside another class. But the question is, why did I not use the name class but I use object here? We have to know this. When a class wants to be called inside the main function, the class does not come into the main function as the class itself, but it comes as a representation called object. So the object is what represents the class in the main function. Is it understood? The object is a variable which represents the class in the main function. Let's say that you have a function addition in a class called addition1. What happens is that, let's say you have a function called addition in a class in Java called grade addition. It does all type of addition. You have a function, a small function called addition in a large class called grade addition. Now, to call grade addition here in the main function, the main function is too small compared to grade addition. So it will not call grade addition by its name, but grade addition, it will call grade addition by an object, by a messenger toward grade addition class, in order to take the function addition. So that's how to see it. So a small link to it, we are going to consider the story of the king and the peasant. A small story I've written. The peasant is smaller than the king. Here the function is smaller than the class, so I compare the peasant to the int main function and the class to be the king. If the peasant needs the help of the king, the peasant won't go to the king and take the king's help, the whole king's help. The king will not come to the peasant as a whole. What the king will do to help the peasant is to send a messenger, and that messenger is equals to the object. So the messenger that the king will send will be equals to the object, and that messenger is the person who will represent the king to the peasant. So now that's the same thing we have to do here. When you have a class, you need to create an object that will represent a class inside the in main function for the in main function for the object to call the properties of that class. You need a messenger who is an object. You need a messenger of the king for the peasant to have the help of the king and not the king. So that's the small story and the small link that you have to take in mind here. So let's involve with data structures. When you want to do a data structure, it's just similar to classes, but they are smaller than classes. Write strict. Write the name of the data structure. Let's say rectangle. You know that the properties of rectangle are all similar. Rectangle have length, and rectangle have length, put a semicolon, and rectangle have width, put a semicolon. Now we need to know that the objects of this rectangle can be written here. You can write rectangle here. Let's say the rectangles I want to calculate will be rectangle 1, comma, these are the objects of the rectangle. This is big rectangle, it's like a king. Rectangle 1 will be object that will represent rectangle in the in main function, and also have rectangle 2. Put your semicolon. Now in the in main function, we are going to assign different values of rectangle now to this length and this rate. So how do you do as such? Normally, when you want to visualize this length and this width in the in main function, since they are if it involved with classes, you have to put the word public, because these words are very necessary in order to tell that the class is leaving the in main function for it to view its value inside, because the class is like a king. It's leaving the in main function to see him or to help him via a messenger, to see him via a messenger. So you need to put a word public when you are involved with classes here. But this is a struct. The struct is in the same class as the in main function, so you don't need the word public. So when it's like this without any word, it's just said to be private, and private it could be seen by any function in the same class, and this struct is found in the same class as the in main function, but it's greater than it. So to see the struct or the king inside, you need to have object. The rectangle 1 and rectangle 2 are the objects. Now I need to call the value length and width in the in main function. So how will I do? I'll use this format as I initially told you, the object that is formed dot the function or the variable. So what happens is that I'll write here rectangle 1, I put dot, I put length as such. So this is n here. I put length as such equals to, let's say it's 10. I need to say that my length here is an integer and my width here is better a floating number. So I'll put a float. So my length is a float and my width is a float too. So all of those length and width. So I'm going to place the in value of rectangle. I'm going to place rectangle 1. I'm going to place 10. Also in the rectangle 1 dot the value of the width here. Value of the width will be equals to, let's say, 5. Now for the next object, let's say rectangle 2. So it's rectangle, now rectangle 2, so rectangle 2 dot, I now have the width here, float width. The width now, let's say, is 20. So length there is 20, and you take also rectangle 2, let's say dot. Yes, it's not calling because I did an error, so I have to cancel a rectangle. I come back and I do dot. It's calling the width. So I put here the width here. Let's say the width is 10 as such. Now when you have rectangle length 1 length and rectangle 2, I can find the area with a function alpha, or I can find the area and say here. I can use a function and send its value inside with their addresses, but I don't want to have that long method, so I'll just say that area 1. So I'll assign 2 values. I'll float, or place another float area 1 is equals to, the float area 1 will be equals to, this value is a variable, so I'll say rectangle dot length. So it's rectangle 1. I cannot call rectangle by itself because rectangle is the whole class. I cannot call the whole class in the main function, so I have to call, it's a whole strict data structure in the main function. I'll call rectangle 1 dot length times, that's the area, rectangle 1 dot length times this one, rectangle 2, rectangle 1 still dot width. So I copy and I come here, I paste, times width. I have this. Now I come to the next one, I write float area 2 equals to, I have rectangle 2 now dot the length, it's taking the length inside. I copy, I come into width, I paste here, then I take times, I take also rectangle this, the width now, I copy, and then I come here and I paste width. I put a semicolon here and I put a semicolon here. So I have this count, I have float area 1, it will contain the rectangle 1 length, the length of the rectangle 1 and the length of rectangle 2 as such. So this rectangle 1 is the first object and this rectangle 2 is the second object, and all of them are containing different parameter of the great rectangle called the great rectangle. So they are going to contain all these parameters, assign the value into it. So when I do it, I can now come, I write count the value, so no, the area of rectangle 1 is, the area of rectangle 1, delete here, space here, delete. Area of rectangle 1 is, I put 2 dot. Now I place here count, I remove this, I place 2 values here, 2 special signs, and I place here area 1, area 1. If I semicolon, go to the next line. So I have count again with this semicolon, the area of rectangle 2 is put 2 dot. I put a space, then I do area 2 and I put a semicolon as such. So when I have this, I can compile and I have this. The area of rectangle 1 is 50, then I have to put them into both lines. So I can put here, then I tap, then I come here, I put down on the next line, then I tap as such. So I have this. The area of rectangle 1 is 50, the area of rectangle 2 is 200. So you have the values. You see that I've assigned these different values to rectangle 1 and rectangle 2, their objects, which are contain the length and the width, and I have this. So you see that object-oriented programming is they're using data structures will be served to arrange your files very well and arrange your data in an orderly manner. You see that here I have just up to 4 variables, but I'm storing each variable within an object. You see that it's very functional, and I can call this each variable with the name of the object. So this will end up. So here we have ended up with the introduction of the data structures, and we have used introduction of object-oriented programming, and we have seen data structures, the direct method of data structures. Now now we are going to see the indirect method of using data structures. So indirect method. Indirect method of using data structures. Now you have this indirect method. The indirect method of using now data structure will be different. So the indirect method, we are going to use pointers and addresses in order for us to visualize these values. So now you've seen that in this method we just use directly the rectangle and .l. Now in this other method, with indirect method, we are going to use the pointers to the data structure rectangle. So how do we do it? So how do we point? Because we are going to pointers, we are going to use pointers to data structures. Pointers to data structure. Now when you have this, you need to put in your mind that rectangle, in order to point to them, you have to put rectangle. Rectangle is a big class, so it's a king. So you have rectangle, which is the king. In the rectangle, you will declare the first object. When I want to declare now, I will remove. There are two methods of declaration. I can either declare here, or I can declare rectangle 1 here as such, and rectangle with rectangle 2. So this method, if I remove this like this method here is similar to this other one here. So this method of declaration of object which are close to the structure, data structure as such, and this other method here are similar. So these are the two methods of declaration of objects. So now this method of declaration will easily be used with the pointers of data structure. So now this is a pointer of data structure with object rectangle 1. So now I'm going to point it. How am I going to point this structure? In order to do a pointer of this, I'll first declare rectangle 1. So I'm calling the object of rectangle being rectangle 1. So now I'm also going to declare another rectangle. In that rectangle, I'm going to instead produce the pointer of rectangle 1. This is a pointer of rectangle 1 as such. And now at the end, I'm going to say pointer of rectangle. We initially know that pointer of rectangle is equal to the address of rectangle 1 in order for me to know that it's actually pointing to the address of rectangle 1, for the computer to know that it's actually pointing to the address of rectangle 1. You have it. And the second method is easy. You just copy the first method but with the pointer of rectangle 2. So you have rectangle here, you have rectangle 2 here. But here it's not just rectangle 2, but it's a pointer of rectangle 2. And now at the end, you end up by saying that P, that pointer of rectangle 2 will be equals to the address of rectangle 2. So these are the two things to put in your mind. So address of rectangle 2. Now, when you use pointers of data structures, you need to know that when you are using pointer of data structure, you cannot use again rectangle 1 length and rectangle 1 this. When you want to use the data structure, you are going now to use the pointers, and to point to the location of the parameter length, we instead use p rectangle as such. This is used to point, this value here is used to point to the parameter length using p rectangle 1. This is p rectangle 1. I'm going to use this pointer p rectangle 1 to point, because it points to the address of rectangle. So here p rectangle 1 is going to point to the address of rectangle and at the particular location of length. So it's going to point to the parameter length, and when it's pointing, it's going to assign to that value 10. The next thing is p rectangle 1. When I do that, I put this. I have width equals to that. I have also here p rectangle 2. I put this. I have that. I also have p rectangle 2. I place this and I have that. So, and I lastly have, in order to have the areas here, I'm going to place p here, I'm going to place p here, and I'm going to place their locations with their address in order to visualize the values which are found within it. So this is an indirect method while using pointers and addresses. So here the address is written as such in order to visualize where it is located. It is pointing toward the address as such. You have this, and your final have area 1, area 2. When you have this, you compile and build. The first error shows up to you, and the error is because you have forgotten a semicolon. Anytime you want to write the data structure, always write a semicolon at this end. Else you can write rectangle on this portion, but when you don't write rectangle 1 and rectangle 2, you don't declare the objects on this line. You can declare the object in the main function. They are the messengers of the king. You place a semicolon there, compile and run. Here they say p rectangle. Here is because I've written p rectangle 1, and here I've just written p rectangle. It's telling me that I didn't declare p rectangle, so I have to place here p rectangle 1. It should be the same. I come here again, I see that this rectangle is p rectangle 2, and this p rectangle 2 is actually okay. Rectangle 1. P rectangle 2. So when you compile and run, it gives this. This is similar. This is a similar answer we initially had when we were dealing with in the direct method of data structures. So this will mark with the end of the introduction to object-oriented programming and the end of C++ programming. Thanks for your kind attention. Hope you will see next tutorials.